Why exactly space? And why does it move? In this video, I will give arguments that will help you understand why space is used in the theory. Why does the space move? Why is the expression movement of space so contradictory? And why the existing theory of gravity is not complete without the movement of space? Probably this video should have been one of the first, but I underestimated the depth of the problem of our perception of the word space. In our minds, under the word space, two concepts that are completely different in meaning are combined. First, it is space as an empty and motionless absolute and measure of everything and everyone. In this sense, this word is used in such expressions as Euclidean space, Minkowski space, and others. And the second is space as a physical object, a certain substance in quotation marks, through which electromagnetic interaction and other physical phenomena are carried out, and in relation to which inertia is manifested. And there is another reason for the problem of perception of this word in the context of the theory. I will talk about it a little later. There was a time when the idea that the Earth revolves around the Sun sounded like the ravings of the madman. And there was a moment when the fact of quantization of energy and the principle of relativity were not at all obvious to the majority. And even today, quantum effects and properties of micro-objects raise many questions at the first acquaintance, because the quantum world is different from our everyday reality, and therefore counterintuitive to us. And in the history of science, there have been a lot of similar cases, when unpopular thought or idea is proved experimentally or by observations, and later becomes a generally accepted fact, which later, for new generations, becomes one of the building blocks of the basement of natural science. Since our perception of reality is built from logical models that are understandable to us, from images and patterns known to us, and our consciousness is always trying to explain new and incomprehensible phenomena through well-known images and phenomena that already exist in our consciousness. And because our everyday reality is limited in the variety of these models and abstractions with which our mind is armed, we still perceive elementary particles as some solid balls, and we collide these balls hoping to understand what subparticles they consist of. And then we imagine that these quark subparticles are held together because they exchange other gluon subparticles. And the photon is still both a wave and a particle. And the greater the energy of photon, the more its behavior is similar to the behavior of a particle. And the lower energy, the more it behaves like a wave. Moreover, there are double-slit experiments in which even electrons and atoms behave like a wave. That is, some objects that in our perception are undoubtedly particles, under certain circumstances, they manifest themselves as a wave. But it's obvious that a photon is not a wave or a particle, but something else. It's just that in our minds, there's no model that would combine such a duality of properties. And therefore, when we hear a statement that contradicts the models and images rooted in our minds, this statement causes distrust or even rejection. But it doesn't happen to everyone. It depends on imagination, flexibility of thinking, and experience in studying various physical concepts and hypotheses. Historically, the space from the side of science was deprived of attention. We dismissively thought that the space was empty, and there was nothing special to explore there. But nevertheless, this in quotation mark emptiness carries out electromagnetic and gravitational interaction. And apparently, without knowing the secret of space and its relation with matter, we will not be able to find an explanation for the effects of quantum world and the wave-particle duality of photons and matter. We will not solve the mystery of the fine structure constant and other phenomena. We need to find out what the fabric of space is, whether it has one layer or is multi-layered. Is it moving or static? And while science has no answers to these questions, in our consciousness the fabric of space will remain empty and motionless. and it will be called by the word space. And therefore, as before, for a significant part of people, the expression the movement of space will cause some rejection. But few people know, or few people have thought about the fact that some of our theories are based on the abstract mathematical models that still do not have a full-fledged explanation. These include electromagnetic field, electromagnetic wave, magnetic field lines, and others. Because it's still not known what this electromagnetic field consists of, what fluctuates in the case of an electromagnetic wave. But these phenomena were very successfully described mathematically, and found some speculative analogies in our minds, such as a field and a wave. And now these concepts are observed by our consciousness from school age, and are laid in the basis of our knowledge about the nature of our world, and therefore very rarely and very reluctantly subjected to critical analysis and rethinking. But how true is the statement that space is motionless from the point of view of science? If in our mind the space is static, and our consciousness rebels when it hears the expression movement of space, then science is not so categorical, and there are reasons for this. Perhaps most of all, consciousness rebels among those who are not familiar with the theoretical basis on which the modern theory of gravity is built, and it's based on the principle of equivalence of gravity and inertia. In other words, modern science puts an equal sign between gravity and inertia. Why so? Haven't you thought about it? Why did Albert Einstein equate the state of rest on the surface of the Earth and acceleration through space in imaginary elevator in his famous thought experiment? Why are there no fundamental differences in these different cases, since in the first case the body rests on the surface of the Earth, and in the second case it accelerates in space? Perhaps precisely because space passes through the body in a gravitational field, which moves with acceleration. And such a movement of space completely eliminates the inequality of these two cases. Or remember the situation with time dilation. Time slows down when a body moves through space, and when a body is at rest in a gravitational field. In the case of motion, time dilation depends on the speed of the body, and in the case of rest, on the strength of gravity. That is on the mass of the gravitating object and the distance to it. But the speed of space has a similar dependence on the same factors. We have a fact in our hands, the principle of equivalence of gravity and inertia. And the equality of the inertial and gravitational masses is confirmed by the numerous experiments. But it's impossible to prove this equivalence theoretically. The only way to do this passes through the movement of space. That is, any theory that claims to explain the equivalence of gravity and inertia must be a theory with the movement of space. On the other hand, if you still think that space doesn't move, then it's not possible to prove it in any way. From the point of view of inertia and the other physical processes, a frame of reference moving by inertia and a frame of reference at rest in space are equivalent and indistinguishable. And this is a principle of relativity. And the equivalence of a reference system moving in space and the reference system relative to which space moves cannot be disputed at all. That is, the expression space is not moving anywhere, from the point of view of science, sounds just as stupid as the expression movement of space, since there's no certainty in science on this issue. But why exactly space, and not ether or some other medium? Historically, it so happened that we observe and measure the inertial properties of bodies in the process of motion or a state of rest relative to space. And when in a school physics we are given the concept of inertia, then, to understand the inertia, there is no need for any specific media or fields. That is, in order to understand inertia, we need only the understanding of space that even a school child has. And if this understanding of space is enough to understand inertia, then it should be enough to explain gravity. On the other hand, if we use space to describe inertia and introduce a specific medium or field to describe gravity, then this will not be correct. this contradicts the principle of equivalence of gravity and inertia. And we have no right to do so if we pursue the goal of explaining the reason for this equivalence. And perhaps that's why the general relativity also uses space. But it doesn't move, it curves. Therefore, in the theory of moving space, space is used, precisely in the sense of the word, in which space is a physical object. And due to the fact that this physical object still doesn't have its own special name, therefore, the general word space has to be used. The only change that needs to be made to the properties of space to describe the gravity is that it's not static, that is, the ability to move. And if you don't like the expression movement of space, then you can imagine that it's not space that moves, but the fabric of space, which is responsible for the inertial properties of bodies. One important thing needs to be understood, that the cosmological redshift modern science explains by the expansion or stretching of space. And this, in turn, confirms that space is a physical object, in which, due to the expansion of space, photons stretch over time. In turn, the expansion or stretching of space excludes any staticity, because if every part of space of the universe is expanding all the time, then there can be no question of the static space. Therefore, the expression "the movement of space" is not anti-scientific. In addition to the mobility of space, perhaps it's necessary to say that it's not compressible. This is necessary in order to fulfill the main condition for acceleration, when the flow narrows. And as mentioned earlier, from the point of view of science, it's a very difficult task to determine whether space is moving or not. But there are some anomalies, such as rotation curves of galaxies, the small tangential velocity of halo stars relative to the velocity of disk stars, the anisotropy of halo stars' velocities, asymmetric drift, and others. And these anomalies can be explained either as dark matter or other unknown phenomenon, or as the movement of space. Moreover, of the four listed, dark matter explains only one, but the movement of space explains all of these anomalies. More on this in video number 9. And the theory of moving space not only explains the listed anomalies, but also provides answers to many mysteries of astrophysics and cosmology. Based on all that has been said, the use of space in the sense of a physical object in the theory of moving space is justified. When the science will give a more accurate description of the space and its properties and realize the true nature of inertia, then it will be necessary simply to supplement the theory with this new knowledge. In the meantime, let's follow the principle of Occam's razor, and we will not produce unnecessary entities. Perhaps there's some misunderstanding about how exactly the force of gravity appears, because gravity is not carried out by the movement of space itself, since the usual rectilinear and uniform motion of the body relative to space, or a similar motion of space relative to the body, doesn't lead to the appearance of any force, because this is the usual movement of the body by inertia. The force of inertia appears when, under the influence of external force, the speed of a body relative to space changes in absolute value or direction, or when the space around the body flows with acceleration or deceleration. And here it's important to understand the main principle of the action of inertia, that inertia always acts against a change in the speed of a body relative to space. And if the space passing through the body accelerates, then the body begins to accelerate in the same way as space. And the statement that gravity is not a force is correct, because in fact the body retains its speed relative to space. That is, when a body accelerates in a gravitational field, this is not the result of action of some kind of force. In fact, it is simply moving by inertia, and the body accelerates because space is accelerating. Also, it may be confusing that the acceleration of space in a gravitational field doesn't occur in time. That is, the speed of space at a certain point doesn't change with time. But the zone of action of gravity is a continuous and smooth gradient of the speed of space, and around every smallest particle of matter, the speed of space is different. And apparently, such a geometric acceleration of space is equivalent to temporal acceleration. This stream of accelerating space looks something like this. how it's capable to displaying a two-dimensional image. And now attention, if time is stopped and this structure is analyzed in statics and make some manipulation with the picture to display the process of narrowing the flow, then this is a narrowing of the flow of space similar to the curvature or distortion of space by a massive object. And to some extent, this is such a curvature of space which is implied in general relativity. But someone may object that the curvature of space in general relativity has the form of a funnel. But the curvature in the form of a funnel is just a speculative analogy and is used only to demonstrate the movement of the bodies in gravitational field. And everyone knows about it, or almost everyone. And relatively recently, a new version of the visualization of the curvature of space in general relativity has appeared, which also takes into account the time characteristics according to the equations. That is, it's not static, but shows the curvature of space in dynamics. And you see the results on your screens. It turns out that in statics it's a curvature of space, but in dynamics it's a movement of space. I will leave a link to the original video in the description, and I recommend to look.